Hey y'all, welcome to day 3 of trig. So far we've talked about similar right triangles and we've kind of figured out how we can set up our trig ratios. So today we're going to kind of put it all together. So the first of all, what you want to do is it says what side is opposite of angle A. So I'm going to circle angle A, or sometimes we'll put this little symbol right here. It's theta to indicate that we're talking about angle A. So it says what side is opposite angle A? Well, if I look across, this side we would call opposite. This side we would call adjacent because it shares a side with angle A. And then across from the right angle is always the hypotenuse. So if we're looking at what side is opposite of angle A, well, that's going to be side C. What side is adjacent to angle A? Well, that's going to be A, B. And finally, what is the hypotenuse? That would be CA. Okay. Having reviewed that, that's going to be extremely important for what we're going to learn today. We're going to learn SOHCAHTOA. You might have heard this before. What does SOHCAHTOA stand for? Well, the S, the A, and the T stand for our trig ratio. So we've got sine, cosine, and tangent. All right, and then the sine, the O stands for, is going to be opposite over hypotenuse. For cosine, it's going to be adjacent over hypotenuse. And tangent is opposite over adjacent. And so which one of these you use depends on the information that you're given. So let's just kind of talk about sine and cosine first, and then we'll talk about tangent in a minute. So the sine of an acute angle of a right triangle is the ratio of the length of the side opposite of the acute angle to the length of the hypotenuse. And the key here is that it always says the acute angle. Well, both of these angles are going to be acute. Both angle A and angle C are going to be acute because they're going to be less than 90 degrees. You cannot use the 90-degree angle in your ratio. The cosine of an acute angle of a right triangle is the ratio of the length of the side of the adjacent side. And I'm just going to put ADJ, but we know that means adjacent. And that's to the length of the hypotenuse. So now we've seen this 3 different times. You're going to need to see it many more times to memorize it. And that's where SOHCAHTOA comes in, just to help you remember. Every time I see a trig ratio, I say SOHCAHTOA, or I write it down in my mind. All right, so the cool thing about trig is that you can pretty much do all of it on your calculator. You just have to know how to use a calculator. So it says use your calculator. You're going to need to take your calculator out. Whenever you do trig, you have to change the mode to degrees. So you literally just click the mode button on your calculator, and you should scroll over so that degrees is highlighted. Hit enter, and you have now changed your calculator into degrees. So when you do this in your calculator, and do practice this now, rather than just copy this off the video, you actually want to take your calculator and practice this. You hit sine of 50 degrees. Well, if they give you what the degrees is, you want to find what the ratio is. So actually you have to hit second, then sine, and then 50 degrees. And make sure you close your parentheses. Right? And when you hit enter, you should get about 0.766. And remember, when you know the angle and you're looking for the ratio, well, all of our ratios are length over length. They're fractions. So you should be getting decimals when you work this out. And some of y'all know how to convert a decimal into a fraction. If you want to do that, you can too. So here for cosine of 50, you're going to hit second, the cosine button, and you should see the sine, cosine, and tangent button. They're kind of in the middle of the black buttons on your calculator. So you hit second, cosine, And then you should get a parentheses, and you're going to put in 50. Close your parentheses. And it should say like cosine -1 and sine -1 when you do that. That means you've got the angle measure and you're trying to find the ratio. And when you hit enter, you should get 0.643. Now, if you're looking for the angle and you're given the ratio, well, then you don't have to hit second. You just hit the sine button, and you'll get a parentheses, and you type in 0.5, hit equals, and you should get something around 30 degrees. And here again, you hit the sine button on your calculator, then you type in 2588, hit your equals, and you should get about, it's like 14.99, whatever. So we're just going to round that to 15. Okay. So now that's if the ratio is given to you, or the angle measure is given to you. Now we have to put it all together. So we're given a picture. You can see here that different side lengths are given, and it is a right angle. Okay. So we want to find the sine of A. So I'm going to go ahead and put my theta symbol here. Sine. All right. Once again, I'm going to think so, okay. So if I want the sine of angle A, I know that I'm looking opposite, which is here, and the hypotenuse, which is there. So that means I'm going to be putting 3/5. I don't have my angle, so I'm going to have to hit second, sine, and I'll get that -1, and literally type in 3 divided by 5 in your calculator, hit enter, and you should get 36.8699. And the reason I went so far is because in the directions it said round to 4 decimal places. I'm going to use the same picture, but this time, see this, I'm looking for the cosine of B. So now I'm looking from this part right here. Cosine is adjacent over hypotenuse, so this is my adjacent side, and my hypotenuse still is 5. So it's the same ratio. Again, I don't have the angle, that's what I'm looking for, so I have to hit second, cosine, and you'll see this little -1, and I'm going to type in the same ratio, 3/5 equals. But this time I should get a different answer because it's a different angle. And I get 53.13. And I stop there because the rest of it rounds off. Now what's interesting is, what do you notice about the values 1 and 2? Well, if I add these values together, you actually get 90 degrees, which makes sense. This one's 30, this angle here, angle A, is 36, let's just say 0.9, and this one here is 53.1. Well, all 3 of these angles should add up to 180 degrees. And if this one's already 90 degrees, then these two should also add up to 90 degrees. The other thing you should notice about question 1 and 2 is that though the fraction's the same in both of these problems, the ratios are different because you're looking at the sine in one and the cosine of the other. So we actually get 2 different angle measures. Well, let's see if that holds true for the second example. Excuse me. So I've got the sine of Q. So I'm going to first put my theta symbol here because that's where I'm going to look first. And again, sine, it's so that's another way you can write your ratios. So it's opposite over hypotenuse. So if I'm looking at the sine of Q, well, the side opposite is here. And this is the hypotenuse. Again, I know that because it's across from the right angle. So it's 5/13. I'm looking for the angle, so I'm going to have to hit second, sine, -1, parentheses, 5 divided by 13, close my parentheses, hit equal, And the value of that angle is 22.6199. So Q is 22, I'll just say 0.6 degrees. All right, now I want to find the cosine of S. So I'll use a different symbol to represent S. And I want to find the cosine. So cosine is the adjacent side. So now this is no longer the opposite side. It is now adjacent over the hypotenuse. And the hypotenuse is always going to be the same. So I'm going to hit second in my calculator, cosine, -1, and the ratio I'm looking for is 5/13 again, but I'm expecting a different result because it's a different angle. And what I get is 67.38. So I'll say it's about 67.4. And if I notice, if I add 67.4 plus 22.6, I get 90 degrees. And again, that's because all three of my angles should add up to 190. So the key is that if you figure out one of the angles, you can just subtract from 90 to get the other angle. Let's look at some more problems where we're going to apply this, and then we'll look at our tangent ratio. You're going to want to take the video right now and pause it and see if you can figure out whether you're finding the sine or the cosine of each of these. Now notice for 1 and 2, you have the angle, so you're not going to use the second button, but for 3 and 4, you will. Ratios that you should have come up with. Now, what I'm going to do is I'm going to type actually the sine of 42 in my calculator, and because I'm trying to figure out what x is, I can multiply this side by 75, and I can multiply this side by 75. So what I'm actually going to type in my calculator is the sine of 42. It's very important that you close your parentheses, and then I'm going to multiply that by 75, hit equals, and you should get 50.2. So that means that this side length right here is 50.2 long. Okay? And the same thing for cosine of 42. This is an equation. I'm trying to look for what x is, so I have to isolate it. This is dividing by 75, so I do inverse operations. And I'm going to multiply this side by 75. So you can type it in your calculator that way, or I like to start out with the cosine of 42, make sure that's in parentheses, then hit your times symbol, 75. You don't want it all to be in the parentheses or you'll get a different answer. And that is 55.7, which means this side right here is 55.7 long. Now for the equations 3 and 4, those you can just do like we've been doing. Again, we're looking for the angle, so it's going to be the sine, you hit second, sine, so it's -1, and then you put your ratio in. 62 divided by 87, close your parentheses, hit equals, and you get the angle measure of 45.5. And this is measured in degrees because we're talking about an angle, so this is 45.5 degrees. And again, you could find this angle real simple by just subtracting 45.5 from 90. All right, and for number 4, again, you're going to hit second, cosine, so you should see this little -1 here, parentheses 62 over 71. And here you should get 29.2. So this angle right here is 29.2. All right. We've just explored the sine and cosine ratios. Please come back to the second video so we can finish off talking about the tangent ratio, and also I can do some examples with you on how to do your homework.